to be a police officer and work at the police station. I want to be a teacher and work at a school. I want to be a firefighter and work at the fire station. I want to be a nurse and work at the hospital. I want to be a chef or a vet. I want to be a scientist. Can you tell me, what do you want to be?
Hi boys and girls, we thank you for joining us yet again to our exceptional, exciting career guidance series. Today we are yet to get into another exciting series on what we will become when we are grown up.
What do you want to be? What do you want to be? What do you want to be? Can you tell me? A chef, a teacher, a firefighter, a scientist or an astronaut, a police officer, a doctor or a nurse. What do you want to be? Oh, what do you want to be?
Up next, we have someone else up next. We have what we call, anyone who knows what an engineer is? Probably I have heard the word engineer before. Right, we've got an engineer coming up next. And as a big baby that I am, I was very worried because I saw it was written fossil contractor. And fossils are normally old things, isn't it?
Yes.
Yeah, so to you, he may look like a fossil, but that's just the company where you work out together. And he's a civil engineer, and I don't know if he's a civil servant. So we are going to ask Elder Simba, isn't it? Yes. We're going to ask Elder Simba to please come. Clap hands for him. He's a civil engineer, and Elder, these children want to be engineers. Some are already going to be pastors.
Great.
So we've got children who want to be engineers. But before we ask you this, to give you this time to speak, I just want to check. They say engineers are very intelligent.
So they say?
So they say, are you intelligent?
It's just a myth, I guess.
It's a myth?
Yeah.
Oh, okay. Do you think engineers are intelligent? Yes.
Everyone is intelligent.
So I want to ask you a question just to check if you are okay. So, a fly is called a fly because it flies, right?
Yes.
So what will it be called if it didn't have wings? No engineer can get this wrong because your engineering skills will be put to question. A fly is a fly because it flies.
Okay.
What will it be called if it didn't fly anymore?
If it didn't
And if you
fly.
say walker, we'll have a problem. What will it be called?
Maybe I'll say probably an insect that is still at development stage, then which will then have wings and fly.
As usual, engineers complicate simple things. Engineering.
Thank you very much for the wonderful time. Like I said, everyone is intelligent. I'm an engineer from the Built Environment department. With me here are my other colleagues. They are also engineers, but from different lines of industry. The built environment is the construction industry, and we are responsible for construction. So basically, in the built environment, we have professionals like architects. These ones that are responsible for all the designs, for coming up with our architectural designs when we want to embark on a construction project. After coming up with the designs, we have civil and structural engineers that are responsible for designing the structural integrity of our structures, either be it buildings or be it roads. Then after going through our structural designs, we have quantity surveyors who then quantify the quantities that are required for us to carry out the construction project. Then when we start then executing the project, the civil engineers and the structural engineers will then make sure the guys that are going to do the construction on site are conforming to the standards that our project was designed on. So we'll then have people like land surveyors that come in to put pegs where our road or where our structure is going to be sited. Then we also then have the people that will then do the actual construction as a team, which then complements the whole built environment department. So for you to go into the built environment department, one common subject that encompasses all these is mathematics. You have to do mathematics, you have to love mathematics, and you have to do mathematics. After having done mathematics, you have to do, when you want to do, or when you want to specialize, when you want to do engineering, you have to do mathematics and physics, so that you'll be eligible to do engineering, because there's a lot of calculations, there's a lot of mathematics that is involved when coming up with designs for our structures. Then when you want to do the designing, which is not the engineering designing, when you want to do architectural designing, you have to do the mathematics. Then you can do with any other subjects that you want for you to do architectural. So probably you can do technical graphics, TG. It will also then assist you with skills of coming up with the designs that we require. When you also want to do quantity surveying, when you only do mathematics and any other subjects that you want, you can go into quantity surveying, because the work involves a lot of calculations, and if you have mathematics background, you are good to do calculations. Then the built environment is a broad industry, I would say, which encompasses people who do consulting services. When you go the route of consulting services, these are the guys that are responsible just for the designing and coming up with our designs for any project that we want to embark. So this end is they offer consulting services, they offer intellectual property, they just use their brains to come up with designs and to come up with what we want to do on ground, and they are paid for that. Then the other side is the guys who then do the actual or the real construction, wherein the consultants have done the designs. Then these guys will then take the designs from the consultants, interpret, and then put it on the ground and do the real construction. So you can also join in with the same professions. You can do those professions from the construction side, where you guys will be responsible for the actual or for the real construction on ground. So this is basically what we have from the built environment.
Thank you so much. Let's clap hands for our engineers. In church, we teach honesty. Anyone who says I understood that thoroughly, especially the quantity and the integrity of the structures. Anyone who can really break the integrity of the structures properly. So now, who has a question? Who has a question? Right, one. Anyone else? Two. Who else has a question? Right, we'll start here.
If you want to be an architect, don't you need geography?
Don't you need what?
Geography.
Geography. Okay, that's the question.
Yes.
Okay, maybe.
Second question?
Yes? Oh, that's the same question.
Oh, so
Okay.
look, if you want to be an architect, don't you need geography?
Okay.
Is that the question?
Is that the only question that we have?
Is that the only question?
Any other questions? Okay, so I'll just respond to this. So if you want to become an architect, like I said, the baseline or the base course that you have to do is mathematics for starters. Then with any other subject that you can do mathematics and geography, you can do mathematics and English, you can do mathematics and technical graphics, you can do mathematics and any other, mathematics, physics, chemistry, mathematics, biology, chemistry, then you can always become an architect. Then probably one other route, there are several routes that we can use for you to become an architect, for you to become a civil engineer, for you to become any of the professions that we've said in the built environment. The conventional one that we all know is you do your O-level, you go to A-level, you do your subjects at A-level, then you go to an university that offers any of these degrees in the built environment. But there is this other conventional as well, though not many like it. You can say at O-level, whatever subjects that you've done, you can apply to an entry level at Polytech or any other vocational training schools that are there. Then you do your national diploma level in any of these lines where probably you want to do architectural field. Then you can do your architectural field there. You do your ND. You are done with your diploma. Then later on, you can also then do your degree.
Thank you so much. Yes, it's a very rare moment. The cameraman wants to ask a question.
No problem.
So I don't know if he's going to face the camera to himself or you may ask a question.
Thank you. Now that you've mentioned mathematics, it seems as if math is so complex, right? Do you have specific maths that you focus on in terms of engineering? Because we get to look at all those math books, right? Then you get to wonder, do we really need all these?
Okay.
So, these questions coming from someone who's allergic to numbers.
Okay.
So,
Okay. So I'll also ask my colleagues to assist me on this one. But if you are inclined or if you want to do any engineering, mathematics is a prerequisite. And there's no mathematics that will say do statistics, do calculus, do mathematics overall from A to Z. It's a prerequisite. Without that, we will struggle to do engineering. So no maths, no engineering.
It's almost like no Jesus, no heaven. I understood it in my context. So I just want to check to make sure that we are okay. So when we have a building,
Yes.
that building, this thing that we see here,
Yes.
is called a building.
Yes.
It's called a structure.
Yes.
So there's someone who makes this thing.
Yes.
Is he part of the engineering?
Yes, it's
Alright.
part of the engineering.
Then what keeps the building strong?
What keeps the building strong?
I
Okay.
always see them putting wires inside.
Okay. So this is the mathematics that we've been talking about.
Mm-hmm.
So the structural engineers who have the mandate or the responsibility of making sure they give us a structure that is integral, wherein nothing is supposed to fall.
Yes.
Everything is intact.
Yeah.
They're the ones who then design. Depending on the weights that the building is going to carry,
Okay.
depending on the people, depending on the use of the building, depending on many other factors that they consider.
So what do you
then
call
they
that
then
person?
choose that's a structural engineer.
Do you understand what a structural engineer is? Do you understand what he is? The one who makes sure that the building never falls.
Yes.
All right?
So they then choose the type of materials that we are supposed to use for it to be able to sustain the loads that we foresee. Then they also then choose the size of the material. Then they also choose the construction method that we are going to use for us to have a structure that is integral.
All right. Any more questions? If there are no more questions, this clap hands for LDC. For those who want to be engineers, no more hating on maths. Without maths, you cannot see engineering. Are we clear? That is Simba 1 verse 3. He that wanted engineering shall believe in maths. Are we clear?
Yeah.
Without maths, you cannot please engineering.
Yeah, maybe just to encourage everyone, maths is not difficult.
No.
Maths is just simple. All we just need to do is just to, because he's the one who asked.
Because for a moment there,
He's the one who
after you said maths is not difficult, there was a host of mosquitoes in the I wanted to really...
Yes.
Maths is not difficult.
You
can do it if you change your
mindset. Yes.
He can do it. He did it.
Yes.
You can also
do it.
Now we together. So if he did it, you can do it too, right?
Thank you very much.
Thank you so much, my elder. You may take your seat. Thank you so much. Just give a fan for him as he sits down.